move forward. So Afifa, if you can take it over from here. Now, this is the actual research that was initiated once we heard the funding was to take place.
So thank you, Dr. Solis. So the pictures that you see here are kind of how we broke up the different compartments in the tumbler composter and what we added to it. And again, this is just presenting some of the preliminary results of phase 1, and phase 1 being the tumbler composters. So we looked at washed, we looked at unwashed, and we looked at the grass clippings, and we added mulch into the last pile. So we collected sargassum and we brought it back to the Erasmus Marine Campus, and we divided it up into 4 different piles, and we have 2 tumbler composters, and in each of those tumbler composters is divided into 2 compartments, so that allows us to do 4 different experiments. And as mentioned, we have a washed pile, an unwashed pile, we add grass clippings to one, and we add mulch or brown clippings to the other pile. And in the mention of trash, when sifting through and making those piles, I did hand pick out the trash as much to the best of my ability that was in the sargassum that was collected, and it represents it, at least in the pile that was collected and what we've had in hand, it represents less than 1% of the total waste that was removed. But you can see that there is wrappers, there's masks, and there was also a razor that was collected and disposed of. So this kind of brings us to the parameters that we are monitoring every 2 weeks. So we look at 4 main groups of parameters. We look at the bulk physical chemical parameters. We're looking at nutrients, which is done in Dr. Swartz's lab at Erasmus. We're looking at metals, which is done in Dr. Ohlert's lab. And we also look at the bacteria analysis. So all of these measurements are done at the Marine Campus. And this brings us to kind of retrofitting the composters. So in conversation with Dr. Ohlert, we've noticed that there are metal screws on the inside of the tumbler composter, and we didn't want that to interfere with the results that we are going to get from the metals analysis. So we decided to kind of retrofit the composter and cover up all of the plastic screws, and anything that's metal that would potentially be exposed to the sargassum inside the tumbler composter. So as you can see, we kind of retrofitted the screws on the inside with screw caps, and we also took the metal axle and replaced it with PVC. So Dr. Ohlert had the idea of conducting a leaching test, so we can get a baseline of the background concentration of these materials and how it interacts with the sargassum once it's in the tumbler composter. And we've also looked at the carbon to nitrogen ratios of some of the preliminary samples that we collected. We did collect 2 of those samples from the Fort Lauderdale facility, the old compost and the new compost, and we did look at it for carbon to nitrogen ratios. And we also, in addition to those 2 samples, we looked at the sargassum that was collected, and we looked at grass clippings and the mulch that was used. So you can see that the sargassum that was collected does have about 55 to 1 carbon to nitrogen ratio. The old compost has a very high carbon to nitrogen ratio, and dilutions do need to be rerun on these samples to get a better idea of what the actual carbon to nitrogen ratio is. The new compost is close to the sargassum that was collected, so it hasn't had as much time to break down. And our cypress mulch and our grass clippings is representative of the carbon to nitrogen ratio that's normally seen for wood chips and mulch, and our grass clippings as well. And then Dr. Swart, I don't know if you have anything to add in terms of the carbon to nitrogen ratios that we have seen.
Yeah, there were some questions in the chat box about that, Dr. Swart. Thank you.
Yeah, no, it looks fine. And I mean, these values from the sargassum are really typical of low, the original ones are typical of low nutrient supply. So, we even get higher values than that on some of the ones that are collected in the open ocean.
Thank you. That's it. Yeah.
So then some of the bulk physical and chemical parameters, some of the preliminary results that we have been seeing, because to date we've collected 2 subsamples from the tumbler composter, and you can see the moisture content has decreased from the first sampling time to the second sampling time. And for the electrical conductivity and the salinity, there has also been an increase in from it was originally set up to when samples were collected 2 weeks after. And finally, for the pH, you can see that there has been a general increase in the pH, except for the unwashed sample, which has a slight decrease. But again, these are only 2 subsamples that are taken, so over time and as more samples are collected, we can get a better idea of where the trends are going. So this brings me to the bacteria analysis and some of the preliminary results that we have been seeing. So originally we were testing for enterococci, which again is used to issue beach advisories and is used in the beach environment. So since we began the project, we switched over to fecal coliform because that's what is used for sewage sludge and land application of biosolids. So we switched over to fecal coliform, but overall that you can see that there are high levels of enterococci in our samples and fecal coliform as well. So for our unwashed samples, you can see that it's relatively stable. Not much of a change has occurred. But for our washed sample, for enterococci, there is a large decrease in the amount of enterococci that was in the sample, and there is a large increase in our grass clipping samples. And you can also see that there is a decrease for our mulch samples as well. And then I'd just like to hand it over to Dr. Stoller to give you a little bit of background about XRF.
Yes, and so part of the laboratory work is to do a comparison between handheld X-ray fluorescence technology and the more sensitive technique that is available in Dr. Ohler's lab, which focuses on ICP analysis. The XRF came from our prior research on preservative-treated wood, where you can put the XRF, use it in the field, take a measurement of a wood sample, and determine whether or not it is treated with a chemical called CCA, or chromated copper arsenate. And it worked really well in the field, providing information in seconds to then sort treated from untreated wood. And so we were thinking that perhaps the same type of technology may be useful in identifying sargassum that may be good for composting or maybe good for other purposes. So we're doing a comparison between XRF and the more sensitive technology. Next slide.
So then the preliminary analysis that we've had for our XRF results is we've consistently seen that strontium and iron has consistently been seen in our samples, the 2 subsample sets that we have collected. And in our first subsample set on November 18th, iron and strontium was consistently seen in all of the samples. Whereas our second set of samples, strontium is more consistent in all of the samples and iron is only consistent in some of the samples. So in talking with Dr. Ohler, we've seen that she's mentioned that the strontium can be coming from the sea salt or seawater evaporation. And Dr. Ohler, I'd just like to hand it over to you if you have anything else to say in terms of our next steps for the metals analysis.
Sure, thank you, Afifa. Yeah, we are going to be looking at the metals using a triple quadrupole ICP-MS. And the exciting thing about this technology is it takes us down a couple of orders of magnitude in sensitivity. So there's been some really great work by Lihia and her colleagues looking at fresh sargassum and some of the metal analyses there. And we're hoping to look at sort of that lower end of the spectrum that doesn't get picked up quite as well by the XRF, so we can expand that range of metals concentration. So Afifa is going to get trained up in clean room protocols and start digesting the samples as soon as we can get them freeze dried. So we'll look forward to updating you with our results soon.